Hi guys, welcome back to the channel. In this lecture, we are going to discuss about the location of plastic hinge in the propped cantilever beam, right? So basically, we need to find the exact location of the plastic hinge in this propped cantilever beam, okay? So basically, static indeterminacy, this is basically the indeterminate structure. Static indeterminacy will be total number of reactions, one vertical, one moment, and one vertical reaction over here. I'm neglecting the horizontal reaction. So total number of reaction are 3, equilibrium equations are 2, so static indeterminacy is 1. Okay. So number of plastic hinges required for the collapse of this structure, number of plastic hinge required will be equal to number of plastic hinge will be equals to 1 plus 1, basically equals to 2. So 2 number of plastic hinges are required for complete collapse of this propped cantilever beam. Okay. So basically what we need to do over here, first we need to draw the bending moment, elastic bending moment diagram, just for the rough idea, right? So we know that the bending moment diagram of this beam, this cantilever beam, which is loaded by a UDL, will look like this. Okay. So the moment will come maximum at this point. This is the maximum moment, mx. Okay. And this is hogging. Right. And this is the maximum sagging moment. Okay. So first and this, let us suppose this mx1, this is mx1, this is mx2, right? So this mx1 is greater than mx2. Okay. This we have already discussed while discussing the incremental load method. Okay. This moment is greater than this moment. So first plastic hinge will form at this location. First, this is the location of first plastic hinge. Okay. So when the first plastic hinge is formed, beyond the formation of the first plastic hinge, we can apply some load. Okay. This structure is not collapsed after the formation of first plastic hinge. We can further load this structure. Okay. Till the second plastic hinge not formed. Okay. So now you can see that when plastic hinge is formed at this A point, right? And let us suppose this is B point. This point cannot provide any extra moment. Okay. This A point cannot provide any extra moment or resistance, right? So this I can replace this support as a simply support. So this is the condition of the structure after the formation of the first plastic hinge. This A support cannot provide any moment, any moment of resistance, right? So now still you are loading this beam. The UDL is there. So its bending moment diagram will look like this. Okay. So the maximum bending moment will occur at the center. This is C. Let us suppose this is C point. This is center. Okay. So you can see that initially the bending moment is coming maximum at this point. Okay. Now after the formation of the plastic hinge, the maximum bending moment is coming at this point. Okay. So our maximum bending moment for this two, if we combine these two things, so it will somewhere lies between, let us suppose this is x1 and this is x2. It will lies between x1 greater than x greater than x2. So our plastic hinge will lies between this x1 and this x2. Okay. And this is all happening due to moment of redistribution. This is due to moment of redistribution. When there is a formation of the first plastic hinge, and this is first, the bending moment diagram will look like this. Okay. Now if you are further loading till the formation of second plastic hinge, this bending moment at this point will not change. Okay, so it will increase like this. Okay, so initially the bending moment was maximum at this point, now it will maximum at this point. Okay, so we need to find this exact location of this x. Okay guys, so and this is basically due to moment of redistribution, so we need to find this location of this exact location of this plastic hinge, right? So why it is not forming at the center, why it is not forming at this x1 distance, we have discussed just now. So after the formation of the second plastic hinge, this is the formation of, this is first plastic hinge, this is second plastic hinge, and this is this portion B. Let us suppose this is C point, this is A point. Okay, so as you know that the bending moment diagram will look like this. After the formation second plastic hinge, we have to find this x basically. So this, at this point, dm by dx will be 0. That means shear force at this point is 0, right? So now if you see, during the collapse, this beam will deflect like this. This is during the collapse. Okay, so direction of the plastic moment will be like this. Okay, so here the direction of rotation is like this, here the direction of rotation is like this, here the direction of rotation is like this. Okay, this beam initially in this position is reflected now in this position, so direction of rotation is like this. So this MP will always be opposite to this direction of rotation. Remember that thing. Okay, so now let us draw first the free body diagram, and this beam is loaded by UDL. Let us draw the free body diagram for this first CB portion. Okay, for CB portion, the moment MP will act like this. There is some UDL. Okay, at the end there is a reaction RB. Okay, and the magnitude of this UDL is basically W. Now this is C part. Now for this AC portion, the direction of the moment MP will be like this. For this portion, it will be again like this. Here is UDL, okay, which is W, and this is reaction RA. Shear force at the end is 0. Why 0? Because dm by dx equals to 0 at this point. Okay, so now if you calculate RB, from here, so RB, first RB into x taking moment about C point. Okay, so if you take moment about the C point equals to 0, so I can write RB into x equals to MP plus W into x by 2. This is MP plus W x square by 2, right? And we know that shear force is 0 at this point, so I can write RB equals to Wx. This is shear force is 0, right? So RB equals to Wx, if we put in this equation, we'll get Wx square equals to MP plus Wx square by 2. From here, MP is equals to Wx square by 2. So this is our first equation. Okay, so from this part we derive the value of MP. MP is nothing but the plastic moment section, plastic moment capacity. MP is plastic moment capacity, right? So now let us come to this part. I can write summation MC equals to 0. for summation MC equal to 0, RA into L minus of X, okay, equals to MP plus W into L minus X whole square over में 2, okay. Again, shear force will be 0, so I can write RA equals to W L minus of X, because shear force is equals to 0 at this C point, okay. So this equation will be W into L minus X whole square equals to 2MP plus W into L minus X whole square over में 2, right. So if you shift this thing here over here, W common, L minus X whole square minus L minus X whole square divided by 2, right, equals to 2 into MP. MP is what? Wx square by 2. This thing will cancel out each other. So this is WL minus X whole square by 2 equals to Wx square. This thing will cancel out each other. So I can write X square over में L minus X square is equals to 1 by 2. So X over में L minus X equals to 1 by root 2, right? So this is the case. So this is the relation we are getting. So if you calculate this thing, 1 by root 2, this is 0.707. So X equals to 0.707 L minus of X, right? So if you calculate this thing, 0.707 divided by 1.707, so X equals to 0.414 L. So the second plastic hinge will form at this point. So this is 0.414 L. Okay. So this is basically the location of the second plastic hinge which is at a distance of 0.414 L from this B point. Okay. Why this is not forming at the center? This is the most important part. Okay, guys. So if you have any doubt regarding this, you can write in the comment section. Thank you very much. We'll meet in the next lecture.